So most reactions that we're going to talk about will occur in solution. That means they happen in water. So you might be mixing two ionic compounds or polyatomic compounds, but you'll be mixing them in water. So in water, those solids can have two possible states. The first option is they might be a solid or a precipitate. And if that's the case, we're going to use the symbol S in brackets like this to indicate that we have a solid precipitate. It looks like this picture here on the right. There'll be some sort of chunky stuff in the solution. Maybe it looks cloudy or like there's little sandy particles. So you'll see a solid thing in there. That's a precipitate, and we use an S in brackets to indicate we have a precipitate. The other possibility is that you have an aqueous situation. So for that, we'll put in brackets AQ. And aqueous means that you have a solution, which means that you can't see any chunky stuff in there. You can't see little particles floating around. Everything is invisible. It's been fully dissolved. So that's what happens like if you mix salt into water or mix sugar into water. It'll look like this. You can't see the salt anymore. You can't see the sugar anymore. It just looks like water, right? It's fully dissolved in the water. That's an aqueous solution. So those are the two possibilities. How do you know which one you've got? So how do you know if you've got soluble, so aqueous, or precipitate, which is a solid, in your water? How can you tell? Well, we use something called the solubility guidelines. You've actually had this from the first day of our class. These are on the back of your periodic table. There's a list of solubility guidelines. The first question I usually get is, do I need to memorize these for tests? The answer is no. So you get to have those solubility guidelines on any sort of assessment. You can use them just like you get a periodic table on any assessment. All right, they're a little bit dry, but we'll go through each of them and then you'll get to practice with Miss Krishnan today. The first rule is if you've got hydrogen, ammonium, or any alkali metal. So that's basically all of group 1, right? The alkali metals plus hydrogen forms all of group 1 on the periodic table. Or ammonium. If you have that in your ionic compound or in your polyatomic compound, that will be soluble with anybody else. So if you have something like lithium, right, that's an alkali metal, bonded to anything, maybe bonded to nitrate. Because it's got an alkali metal in there, it's going to be soluble. And so what we would write is AQ, and that stands for aqueous, which means it's soluble, right there. The next rule is nitrate and acetate. Those are both polyatomic ions. If they're in any compound bonded to any metal in an ionic compound, you will have a soluble situation. So let's say you have maybe iron, let's say iron 2 nitrate. So it'd be iron, nitrate here, charge of 2 on that iron. That's going to be soluble. Doesn't matter what metal you've got, it's going to be an aqueous situation because of the nitrate. So nitrate and acetate in anybody is going to make a soluble compound, so you'll put aqueous there. Now we get into the exceptions. So chlorine, bromine, and iodine, if those nonmetals are bonded to pretty much any metal in an ionic compound, it will be soluble, with a few exceptions. So if you've got chlorine, bromine, or iodine bonded to silver, lead, specifically lead with a charge of 2, mercury with a charge of 1, copper with a charge of 1, or thallium, then you'll get a solid. So with these guys here, silver, lead, mercury, copper, thallium, those ones will give you solid precipitates. Everybody else, any other metal, will be an aqueous situation. So here's what lead 2 iodide precipitate looks like. So you can see it has that grainy, sandy look, and it's yellow. That's a precipitate of lead 2 iodide. Now, if you had lead 4 iodide, that would actually be soluble. It would be aqueous. So you wouldn't see that chunky precipitate in there. Fluorine is soluble with all metals except for magnesium, calcium, barium, and lead 2. So let's say you have maybe the magnesium. We're going to bond that to fluorine. Magnesium has a charge of 2. Fluorine has a charge of -1, so we're going to need F2 there. That would be solid, right? Because it's fluorine is soluble with everybody except magnesium, calcium, barium, and lead 2. Sulfate forms soluble compounds, again, with everybody except for calcium, strontium, barium, and lead too. So let's say you've got calcium bonded to a sulfate. Sulfate is SO4, charge of -2. Calcium is a charge of +2, so that's a 1-to-1 ratio. That will actually be a precipitate, so that would be solid. But sulfate bonded to any other metal would be aqueous, that would be soluble. Sulfide, so that's just a straight up sulfur, is going to be soluble only with group 1 and 2 cations, ammonium and hydrogen. Everybody else will actually form a solid precipitate with sulfide. So that means if I have something like a group 2 cation, like maybe beryllium bonded to a sulfur to make beryllium sulfide, that would be soluble, so we put aqueous by that. But anybody else bonded to a sulfur, like maybe iron with a charge of 2, let's say, iron 2 sulfide, that would be FeS. That would be a solid, because that's not part of group 1, group 2, ammonium, or hydrogen. Hydroxide forms soluble compounds with group 1, ammonium, and hydrogen, strontium, barium, and thallium cations only. Everybody else will be a solid, but if you want aqueous, you'll need group 1, ammonium, hydrogen, strontium, barium, or thallium. Here is what it looks like if you have nickel 2 bonded to hydroxide, so that makes a solid precipitate, right, because that's not part of those categories that are soluble. And it's kind of a cool, sludgy, cloudy green one, so that's nickel 2 hydroxide. And last but not least, phosphate, carbonate, and sulfite ions, so sulfite is SO3, charge of -2. Those form soluble compounds only with group 1, ammonium and hydrogen. Everybody else will be solid. So if you have, say, maybe calcium bonded to carbonate, CaCO3, that's going to be solid. These guys will form solid precipitates with almost everyone except for group 1, ammonium and hydrogen. And that is your solubility guidelines.